Good morning all. In last lecture we have seen about piezoelectric transducer, its working, everything. And in last lecture we have also seen the output voltage of piezoelectric transducer. It is nothing but the product of your voltage sensitivity G into thickness T and your pressure P, pressure applied. So based on this equation, a problem has been asked here. It is a 2-mark problem. So a piezoelectric crystal has a thickness value has been given. It is 2.5 millimeter and voltage sensitivity of 0.5 volt meter per Newton, and we are asked to find the output voltage when it is subjected to a pressure of 1.6 into 10 to the power 6 Newton per meter square. So as every values are in meters, we have to convert the thickness also in meter. So a millimeter can be converted into meter by multiplying it by 10 to the power minus 3, and we are substituting all the values in the formula of output voltage. So multiplying all these values, you will get the output voltage E0 is equals to 200 volt. And one more problem is also been asked in piezoelectric crystal. So a piezoelectric crystal have a dimension of 5 millimeter into 5 millimeter into 2 millimeter. So this shows the dimension length into breadth into height. Your height is nothing but thickness. So in order to substitute the value of thickness, you can use the height, that is 2 millimeter. And voltage sensitivity is given as 0.05 volt meter per Newton. And it is been employed for measuring the force. So yeah, we have to find the value of force required to develop the voltage of 150 volt. That is, the output voltage is given as 150 volt. So the formula for your force F is given by output voltage divided by voltage sensitivity into thickness of crystal, and this whole thing is multiplied with the area of crystal. So this is the formula for force, what we have already seen in the previous derivation. So substituting these values, output voltage is 150 and your area of cross section is 25 millimeter square. We have converted into meter square. So 25 into 10 to the power minus 6 meter square divided by the voltage sensitivity is 0.05 and thickness is, I have converted the thickness value into meter. So it is 2 into 10 to the power minus 3, nothing but 0.002. So finally I get the force value as 37.5 Newton. And these are some problems. These type of problems can be asked in university exams on piezoelectric transducer. And next topic is photoelectric transducer. So we have seen many type of photoelectric transducer in our daily life. Even solar energy is being obtained with the help of this type of photoelectric transducers. So when radiation of light falls on a photosensitive element, that is, light energy is given to the photosensitive element, it will emit electrons. Electrons are emitted from the surface of that element. So light energy is converted into electrical energy. This is what the principle which is followed in phototransducer. And your phototransducer is classified into two types. One is active transducer and passive transducer. So the example for active transducer is photovoltaic cell, what we use to convert heat energy into electrical energy. This is in the field of electrical and electronics engineering. This is the main research area, your photovoltaic cells. Even in spacecrafts, they use photovoltaic cells in order to get electrical energy for the rover boats, etc. And passive, that is photoemissive. Passive transducer has the examples of photoemissive and photoconductive transducer. We will see this explanation for photovoltaic, photoemissive, photoconductive in the next slides. Before that, I like to explain the photoelectric transducer with the help of animated video. And here is the video which explains the effect of photoelectric effect. And as I said earlier, it is going to have two photoelectric element, that is it is termed as cathode and anode, that is negative terminal and positive terminal, and it is termed as cathode and anode. It is connected to the ammeter, and if light, that is photons, is being directed towards that cathode, that is photoelectric element, electrons are emitted from the cathode and it is passed to the anode. Your positive element is nothing but anode. So electrons emits light when shines on it, and this is carried out using the ammeter, and this is the process that is happening in a photoelectric effect, and this is termed as photoelectric effect. I think this video will explain the photoelectric effect clear way. And coming to the types of photoelectric types of photoelectric transducer, it is first one is photovoltaic cell. So photovoltaic cell will be having, here's the construction of your photovoltaic cell. It will have two types of semiconductors placed over and over. So first one is P type and second one is N type. Here are P type and N type semiconductor which is placed with a forming a junction, and this semiconductor layer is covered with two electrodes, that is lower electrode and upper electrode, and there is an anti-reflection coating. That is this anti-reflection coating. Why? Because the light rays may be reflected. So we should know if light rays are reflected, the amount of energy produced will be reduced. So in order to avoid that situation, we are using an anti-reflection coating on it, which will not make the light energy to reflect on the surface. And this N type will act as a cathode, and this P type will act as an anode. When light falls on the cathode, it emits electrons and it is passed to the anode, and it is being given to the load as the diagram. And coming to the construction part, it is made of selenium. That is your P type and N type semiconductor are made of selenium with an iron base, and it is covered with silver or gold, which is going to act as an electrode. The upper and the lower electrode are made of either silver or gold. So this is the operation. When electrons are emitted to the silver selenium surface, when light strikes, can be collected at the cathode, and it will emit electrons, and it is given back to the load. So the advantages of your photovoltaic cell are, it is simple in construction, it is going to produce high current, and it is one of the active transducer. It does not require any external source for the operation of your transducer. Coming to disadvantages, it is high sensitivity galvanometer is required, and also one more disadvantage is amplification of the output signal is going to be very difficult in photovoltaic cell. That is one of the disadvantage of your photovoltaic cell. And the next photoelectric transducer is photoemissive cell. This is one of the passive type of transducer. So it has, here's the construction of your photoemissive cell. There will be a placement of anode and cathode. The cathode is nothing but it is a curved metal plate. That is the cathode is having the construction of curved metal plate in order to absorb the radiation, that is photons from the light energy, and it is covered through a glassy vacuum tube. There is vacuum inside the tube, and when radiations are passed to the cathode, the process is going to be the same photoelectric effect is going to happen. And the cathode, it has a curved metal plate and is made of either cesium or oxidized silver, and anode, it is made of either nickel or platinum. So the process is going to be similar, but one more thing that has been added is, in order to detect less sensitivity radiation, even when less radiation is passed to the cathode, multiplier tube, photomultiplier tube is used, and here is the construction of the photomultiplier tube. This will multiply the photons, and more number of electrons will be generated. That is what the actual purpose of this photomultiplier tube. The photons are multiplied with the help of diodes, and these diodes will reflect the photons and electrons produced in a longer way, and it will amplify the electrons by multiplying. That is what it is happening in this photomultiplier tube. So when radiation passes to the photocathode, primary electrons are emitted, which get repeated collision. This repeated collision is occurred due to this diodes, by string of diodes, and due to this, photocurrent is produced even at low potential. Even when low potential is given, the current what we need can be obtained with the help of this photoemissive cells. And the advantages are, it has increased sensitivity, it can produce maximum current even at low potential, and instantaneous emission of electrons will occur in this type of photoemissive cells. And the disadvantages are it is a passive transducer it is one of the type of passive transducer, so it is going to be one of the disadvantage. Why? Because we have to add one more external supply for the operation of your transducer, and it is more expensive. Why? Because it has been added with photo multiplier tube, everything. This will increase the cost, and it will become more expensive. And another type of your photo electric transducer is photoconductive cells. That is, this is simple. This circuit you have been seen in your lab. That is nothing but LDR. That is light dependent resistor. So generally we have seen the line following robot project in many competitions. This line following robot will be having this LDR, that is the photoconductive cells, light dependent resistor. At the bottom, it is this have a dark surface and a lighter surface. The lighter surface will reflect more amount of light, whereas the dark surface will reflect less amount of light. So with the help of this phenomenon, this LDR is used to follow a particular track, and your robot will follow a particular track, and it will move only through the track. If it is going to a high surface, high reflecting surface, the sensors will make it move towards the low reflecting surface, and it will follow the low reflecting surface alone. This project has been used widely, and the photo principle works in the principle that resistance of photosensitive semiconducting material decreases with the intensity of incident light. That is what this is what the principle is being used, and varying this intensity, the electric current flows in the circuit. And this cell is made of 3 layers. One is selenium and copper, and it is covered by a silver film. It has the first layer is copper, and second layer is selenium, and it is coated with the silver film. As I said earlier, it is given to the load through a supply. Why? Because it has been a passive transducer. It needs some external supply. And advantages are it is going to be simple and low cost. It will be look very small. And disadvantages is going to have a sluggish performance. There may be some sluggish performance due to some improper working of your transducer, and the impact of hysteresis effect will be there in this photoconductive cells. And this is what about photoconductive cells. And next topic is Hall effect. Hall effect. I like to explain this Hall effect with the help of a video. This Hall effect is named after the person Edwin Hall. That is why in 1879 he have found this Hall effect. The effect is nothing but we are going to place 2 magnets over it. It is going to produce magnetic field. This magnetic field is being measured with the help of this Hall effect sensor. Why? How is we are going to place an electrical conductor between these 2 magnets, and we are going to connect that metal with the wires, electric cable, which is connected to the battery. And this metal is again connected with the wires, electric cables, which is connected to the voltmeter in order to measure the voltage. So when battery is turned on, it produces charges which is passed through this metal conductor, while the electric fields or magnetic field is interfering this flow of current. And this interference in the flow of current will make some amount of potential, and this potential is passed through this electric cable, and it is measured in this voltmeter. So the magnetic field deflects the electrons. The electrons passed from a battery in a conductor, creating a potential difference. So based upon the potential created, we can measure the value of magnetic field. This is how we are measuring the value of magnetic field. So as I said earlier, Hall effect is discovered by E.H. Hall, Edwin Hall in 1878 from an experiment using a metal segment. Hence it is called as Hall effect. And the semiconductor device which are made in use with detecting magnetic field is called as Hall elements or Hall generator. That is, the metal which is placed in between that magnets is nothing but Hall elements or Hall generators. The formula for Hall voltage is VH. It is denoted by VH is equals to 1 divided by D into B into IC into RH, where RH is Hall's constant, its unit is meter cube per C, and B is nothing but your flux density, and IC is electric current, its unit is amp, and D is thickness of the semiconductor. And this is what the diagram that shows the effect of it is. Hall effect can be done in either N type and P type. This is what the diagram.